Okay, so we're going to go ahead and graph the inverse of an absolute value function. And so this is another one of our special graphs. We did the piecewise function in previous videos. We know that we've seen that absolute value has a V shape. Okay? And so one of the things that we've talked about is if I do not know what it looks like, I'm actually going to go ahead and create a table to graph this guy. We can use transformations, but we haven't talked about that yet. That's in the next section. But if I pick a couple x values and see what happens, so for example, if I pick -2, well, if I plug -2 into the function, that's going to equal 0, right? So I know my result is 0, so I can plot that point. So at -2, we're at 0. Okay, so now let's try another one. Let's pick when x is equal to -1. Let's see what happens. So if I plug -1 into the function, that's going to equal the absolute value of 1. So 1 is the y value. So at -1, so when x is equal to -1, I'm going to equal +1. Okay? Remember, we've got to keep on considering our generic shape. I know I'm going to have a y value, and so, or excuse me, a v shape, and so if I try 0, well, 0 plus 2 is 2, absolute value that is 2. I see this shape taking effect here. I'm kind of seeing this right now, so that's the beginning of this absolute value function. So I'm going to create another table, and I'm going to say to myself, okay, I think I've done enough to the right to see a pattern. So now I'm going to go ahead and see what's on the left. So on the left side, the next point would be -3. So let's see what happens. It might go below, it might go above, I don't know. If it goes below, then we need to continue until we can generate this V-shaped graph. So if I plug in a -3, and we're just looking back at our original equation. If I plug in a -3 plus 2, it's -1. Absolute value gives me a +1. So at -3, which is right here, I'm at a +1. And we can already determine that that right here is our V shape. And we're going to go ahead and just kind of draw our line like this. Okay? And so that's our original function. Now what I want to do, though, is I want to graph the inverse. Well, what do we know about the relationship between the inverse and the original function? We know that x and y switch. So I'm going to take just a couple key points. I'm going to take this guy right here, this guy right here, and this guy right here. I'm going to take 3 points and just switch them. So switching them, I'm just going to read from the graph real quick. We have -2, 0 is this coordinate right here. This is a -3, 1. And then this one is a -1, 1. So the idea is the -3, 1 is going to change to the 1, -3. And that's in our inverse function. -2, 0 is going to change to 0, -2, and -1, 1 is going to change to 1, -1. For absolute value functions, parabolas, when we start talking about those, this is the process that you can go through if you want to graph it. And so I'm going to get a different color here, and we're going to go ahead and graph these guys. So I'm going to plot all these guys. So I'm going to plot 1, -3, 1, 2, 3, okay? I'm going to plot 0, -2, so 0, -2, and it's supposed to be a V shape, right? And then 1, -1. And that gives us our shape. And remember, from one of the previous videos, we know that an inverse function is also a reflection off this diagonal of the line y is equal to x, right? Because y is equal to x, they switch. And if you notice, you can kind of picture this flipping over. If you folded the piece of paper like the other video, we can even see right here that this piece and this piece have the same exact slope. And even the same length if we're kind of looking at that connection between this vertex and that vertex. And this is a way that you can easily graph an inverse of another function.